Hello, this is Alex Ketchum, and I'm going to be doing problem 3 from test 1. The first question asks us to draw a circle representing each charged object on this here coordinate axes. We have 3 objects given on the test problem right here. So our first sphere is going to be positive, and it's going to be at negative 2e to the negative ninth, 0, 0. We're told that each of these markings is 1 times 10 to the negative ninth meters. So we're going to go over 2 markings, draw a circle here, and just so we know, we can label it as positive, just so we can remember ourselves, and because it asks in the question to label it as positive or negative. The second sphere is at 2e to the negative 9, 0, 0. So we're going to go over 2 because each one is 1 e to the negative 9 meters. And since it's positive, it's going to be on the positive x-axis. It's going to be right here, and it's going to be negatively charged. And then the third sphere has the vector 0, 2 e to the negative 9, 0. So that goes 0 on the x-axis. It's going to go up 2 on the y-axis. So it'll go right here. And it's 0 on the z-axis, so we don't have to worry about that. And it's going to be negatively charged as well. Alright, and then on the grid, it's also asking us to draw and label an arrow representing OBS location, which is given to us as the vector negative 2e to the negative 9, negative 3e to the negative 9, 0. So it's going to start at our origin. So that's going to be the tail of the vector right here. And it's going to go down, it's going to go in the negative x direction, 2e to the negative 9, and in the negative y direction, 3e to the negative 9. So we go over 2, down 3, it's going to be about here. It's going to be the end, the point of our vector, and we'll draw it like that. So that'll be the first part. Now, those would be part A and B. Part C is going to ask us to write in the lines of code that will allow us to calculate the net electric field at the observation location, display it as an arrow, and calculate its magnitude. Okay, so you're going to have to calculate the magnetic field at each of the 3 points and then add them together. So the distance from point 1, we're going to go right here. Our distance from positive point 1 is going to equal OBS location minus position 1 dot pause, because you have to write dot pause so it'll use the position from the previously named position 1, which is already given to us. It's already named. So to find the magnitude of this, so you're going to find the magnitude of, this is going to give you a vector. If you're doing this by hand, you would just subtract these and get the vector, but the computer does it for you. So to find the magnitude of this point, you're going to have the square root of, well, it's basically the Pythagorean theorem, because how you find the magnitude in real life is x squared plus y squared plus z squared, the square root of that whole thing. And here you can just do rp1. We have rp1 here, so for the x, so it's you just write rp1 dot x, and and that excuse me, and that will give us the x coordinate, or the x part of this of rp1. So then and then 2 asterisks square is raised to the, and then 2, so squared, plus, and you're going to do rp1 dot y squared plus rp1 z squared, running out of room. But you're going to square it, so it's the square root of all that. So it's rp mag, r1 mag, I'm sorry, rp1 mag. Then rp1 hat is just going to be rp1 divided by rp1 mag. Alright. So now you find, that gives you the E field, the E of 1. That's the electric field of 1. And that this allows you to calculate the electric field of 1, which is going to be K, which is 9e to the 9. Q over R magnitude squared R hat. So to put this in, so this is just what we're doing. This is not going to be put in the computer, but this is what we're doing. So to write this for the computer to understand it, you're going to write E1 equals K, which we've already defined, Q, which we've already defined, R mag, which we just defined up here, divided by, I'm sorry, that didn't make sense. R hat, which we defined up here, divided by R mag, and how we just did the square, like I said, double asterisk 2. So that's how you find, you're going to do that for each point, and you're going to, so that's how you find the electric field for E1. And then you're going to repeat this each time to get the electric field at E2 and E3. Exact same way, it's just going to be a plug and chug from that point on. And then you're now going to find E net. So once you find E1 and E2 and E3, the E1, E2, and E3 are all now defined by the computer, and you can just go E net equals E1 plus E2 plus E3. Alright, so now for the part D, let me get a new piece of paper. For part D, it's asking us to write a line of code to calculate the magnitude of the electric field. So to do this, we already found, it's the same way you found R mag. You're going to say E mag is going to equal the square root. It's, once again, we're trying to basically finding the Pythagorean theorem. So it's going to be E1 squared. No, that's wrong. I'm sorry. It is going to be E mag, E net, and the x component squared plus E net y component squared plus E net z component, once again I'm running out of little room, squared. Oh, right on my desk. And that will give you E net. E net mag, the magnitude of E net. Sorry, E mag is what we wrote here. Alright, and then to display an arrow representing the net electric field vector, you have to write an arrow. Well, the question says arrow pause equals blank axis equals blank. Well, the first one's going to be obs location. And then the last part is going to be E net. And that's because the position of the arrow is going to be at the observation location, and the axis will be along E net, which we just defined. So that's how you do the third problem on test number 1.